All right, welcome to another class with Mathemasoft, and this is the continuation of our class on partial fraction. In this video, we'll be solving more examples on partial fractions, and this may just be another category of how we can actually split an algebra fraction into its partial fraction. So we have the question: express the following as a sum of partial fractions. Okay, so let's begin. Solution. We have our number one. We have 5x squared plus 17x plus 5. And then we have x plus 2 squared. So just as I've actually explained in the previous classes, the first thing you need to check is for you to check your denominator. Okay, so if we should do a longer expansion of this denominator, we know that this first part will result to the power of x as s raised to power 2, and multiplying by what s raised to power 1 here will give us s raised to power 3. That's just for us to be sure that it is not an improper fraction. We know that denominator will result to the highest power of x as s raised to power 3. So if you compare it with your numerator, which has a highest power of x as 2, that shows that that is not an improper fraction. So we can now think about how we are going to do the splitting, because what we have here actually shows that this is a repeated factor. Okay, so this is a repeated factor, just as I explained in the second class on partial fraction. So being that is a repeated factor, it means that while splitting, okay, let me write it in a way that they will be together. So we have x plus 2 raised to power 2, x plus 1. So we are going to split into a over, so this repeated factor first, that's x plus 2, okay, as the power of a 1, and then plus a over x plus 2 raised to power 2. If you have not watched my second class on partial fraction, so you need to go and watch that video. I've already explained all this. So this is how you do this splitting. And then the third one, we are done with this now. So this will now be c over x plus 1. So this is plus. Okay, so that's what we have right there. So this is how our partial fractions will be, resulting from this particular model fraction. Then we can continue with writing our LCM. Obviously, our LCM will be x plus 2 okay, square bracket x plus 1. And then if we say this in all this, will give us a bracket x plus 2, okay, one of it will cancel out, and then x plus 1. Okay, so this is what we have. Let me clean this. All right, plus, if we say this in this now, will give us just x plus 1, so that will be a bracket x plus 1, and then plus c bracket x plus 2 square. So this is what we have. Now we can compare now, since our denominators are the same, okay, on both sides. So it means that we can equate the numerator um, to each other also. So we have 5x squared plus 17x plus 5 now is equals to a bracket x plus 2 x plus 1. Okay, pardon me, this is actually b. Oh, this is b, sorry for that. This is b. Okay, we must use a different letter entirely. So that's b. So this will be plus b into bracket x plus 1 plus c into bracket x plus 2 raised to power 2. Pardon me for that. So that's b. You must actually use a different letter. All right. So now we can begin to look at this in a way to eliminate some of our, you know, unknown. That's the three unknowns we have here are A, B, C. So these are the unknowns that we want to get. Once we get this, the value of A, B, C, we plug it here and then we are done. So that's the unknown that we actually want to find. So looking at this, we can actually see how we can, eliminate using elimination method. So if we look at this, if I put my x as a -1, okay, that will make this to be 0, and this also will become 0, so leaving us with this, so we can find our c. So let us do that. We say put x equals -1. So if we put x equals to -1, that will be 5 bracket -1 square plus 17 bracket -1 plus 5, okay, equals a. Of course, this will be 0, so I don't need to be writing it, just like stressing ourselves. So if we put that as -1, we already know that it is going to be 0. This also will be what? 0. So only c we are writing now. That's c bracket -1 plus 2 square. And then this will give us 5 bracket 1. That's what it will result to. This will be -17 plus 5 equals c, and then we have -1 plus 2 will give us 1 square, and that will be 1. So that means that we have 5 minus 17 plus 5 equals to c. C equals 10 minus 17. C equals to -7. So our c equals -7, and then we can now go back to our equation, I mean this. So go back to it. Let's see another way we can actually what? Eliminate something else there. So if we plug in x as -2, if we plug in x as a -2, another thing that can actually result from that is that this will become 0 and this also will become 0. So leaving us to find a b. So let us do that. Okay. So we say put x equals to -2. So that will make this to be 5 bracket -2 square plus 17 bracket -2 plus 5 equals a will become 0. Entire thing about a will become 0. So we don't have to write it. That will be 0 plus only b will remain, which will be -2 plus 1. Okay, plus everything about c will also become what? 0. So this will give us 5 bracket 4 minus 34 plus 5 equals -2 plus 1 will give us -1, so that will be minus b. Okay, that will be minus b. So this will give us 20 minus 34 plus 5 equals minus b. That's -14, and that's -9. So -9 equals minus b, and that will be b equals 9. We divide both sides by what? -1. Okay, so that's what we have. And now we need to find we have gotten b, we have gotten c, we need to find our a. In order to find our a, the possible things that we need to do here is for us to actually expand, okay, to expand everything, so that we can actually compare the two sides. So that's the visible thing. So let's have 5x squared plus 17x plus 5. So if we multiply everything here now, okay, it will give us a into brackets. We want to multiply x plus 2 times x plus 1. So that will give us x squared. That will be plus x plus 2x. So that's plus 3x. You can do the long expansion, okay, if you you are actually a bit confused about the way I'm expanding. So what I'm just doing is just expanding this, okay, and then that will be plus 2. Okay, that's what we should have, and this will give me b bracket x plus 1. So that's also c. Don't forget that what we have here is a square, so we also try to expand that. I'll give us okay, plus c into brackets. So if we are to expand that, that will give us s squared plus 4x plus 4x, okay, plus 4. Okay, that's what we'll have there. Now we expand everything. 5x squared plus 17x plus 5 equals as squared plus let's just say a, okay, or 3ax rather. That would be better. 3ax, okay, plus 2a plus bx plus b. I'm expanding, opening everything up, okay, plus cs squared plus 4cx plus 4c. Okay, that's what we'll have. Now let's do like terms. 5x squared plus 17x plus 5 equals, so we have as squared plus cs squared. Those are the terms in s squared. So let's take the term in x. 3ax, that's x, okay. The one that also contains x is this, plus bx. So you look for another one that contains x. This also contains x, plus 4cx. Now those ones that are constants that do not have what x, that is a plus 2a plus 2a plus b plus ordinary b and then plus c. I think I've underlined everything. Plus b and then plus 4c plus 4c. Okay, so this is what we have, and then we can now say 5x squared plus 17x plus 5, okay, equals this is a plus c s squared. I'm settling this, plus this also is 3a plus b x. We are not done. We are not done. Plus b. I think there is also 4c plus 4c. Okay, those are the coefficient of x, and these also stick together. We have 2a plus b plus 4c. Okay, so now we can compare our left hand side. We can compare it with what is equals to the right hand side. So if it's equals to the right hand side, so we'll begin to compare. So this is the coefficient of s squared, but here this is the coefficient of s squared. So automatically it means that what our a plus c equals 5. That's what it means. And don't forget that what we are looking for is our a. We have actually gotten our b, we have gotten our c. Okay, that's the end of the road for it. So we can just plug in c. Recall that c is minus 7. So recall that what c equals to minus 7. So we can say a plus c equals to 5 now. A plus minus 7 equals to 5. A minus 7 equals to 5. A equals to 5 plus 7 equals to 12. So therefore we have gotten our a, we have gotten our b, and we have gotten our c. Therefore a equals to 12, b equals to 9, c equals to minus 7. So this is what we have. You can use any of them. Even if you try to use this, okay, you know you already have your B, you already have your C. That means that 3A plus B plus 4C, you are going to equate it to 17. It will still give you A equals to 12. You can try it on your own. If you say you are not satisfied with that, you still want to try the constants. If you do 2A plus B plus 4C, you equate it to what? This 5. It will still give you, the value of A equals to 12. If you have different values, it means that something is already wrong from, the onset of solving this. Now we can now write our partial fraction. Okay, we can express out our partial fraction. Let me copy that to make the work easy. I just hope I'll be able to copy everything. Okay. Oh, good. That makes it easier. So we can now write, paste. Okay, so that's easy now. So we can now just write, okay, the C. Just put in the value of our A, the value of our what? B. So we have our A as 12, we have B as 9, but because C is a minus 7, so this minus will affect this plus, plus times minus, so that will be minus. So that's the only thing. Okay, so this will be minus 7. So this is the what? Partial fraction. That's the splitting of the partial fraction. If you want to try it, if you try to combine all these, okay, try to combine all these partial fractions, and see if it will give you what? This whole fraction. Definitely it must actually give you. If you are doubting and you just want to do the work, so you can actually do that. Thank you very much for staying with me in this class. So obviously I wouldn't want this video to be excessively long. Let's solve the number 2, this number 2. Let's solve it in the next video. Okay, thank you. Please do share and subscribe if you have not done so. Bye for now.